everyone on this new episode of Let's Talk AI. Super happy to be here today. I am with Hala Nelson. Hala, how are you doing?
I'm good. How are you, Thomas?
I'm very good. Super excited to be on this new episode, learning more about data and AI. I have a lot of interesting questions. I found them interesting that I want to ask you. But first of all, for the people who might not know you, could you introduce briefly yourself?
So I'm Hala Nelson. I am from Lebanon. I am a math professor in the United States at the University in Virginia, James Madison University, and I am a writer. I wrote a book on AI and math, and I'm writing a new book on AI and data. So yeah, I'm an author. This is like kind of me.
Awesome. Well, I'm super happy to have you on the podcast. On our previous talk, we discussed about a very interesting project that we can approach today. Um, First of all, I'd like to ask you what you're trying to achieve on this date in the field.
I am trying to build bridges. I feel like this is like what I can do is build bridges that need to be built between fields that are very connected, very dependent on each other, but no one had told the story on how they interact and exactly what from this field we need to do in that field, etc. So when I wrote the book on math and I knew math. I'm a math professor, and everybody used to say, like, if you know math, then you know data and you know AI and you know data science. And in my mind, I'm like, I'm a math professor and I don't know any of that stuff. So there is something in there that needs to be told that's not being told, and exactly what in math we need in that field and how does data and AI contribute to math and exactly. So I sat down and I wanted to teach a class on the subject, and I couldn't find a book that actually connects the two without like going into encyclopedia on I don't know, linear algebra or probability. Or so I ended up having to write the book myself, and then the same I'm doing now with building bridges between the computational, the modeling community, and the scientific community, and the industrial community, people who use this stuff every day in their life, in their products, in their decision making processes. And I also feel there's a disconnect there between the models and the scientific part and the um, you know uh, foundation, the application part on one hand and the business part on the other hand, and also down on the engineering level, the infrastructure, the fundamentals. So I feel like I'm always somehow stuck in the middle, but I want to be in the middle because I want to connect all these things in an easy way, not in a very difficult language, more like
Hmm.
colloquial language, but without compromising the correctness and the detail, the important detail, not all the detail.
Hmm. Yeah, and you mentioned that. Yeah, I'm truly aligned with that because there are those bridge that needs to be created, whether it's academic in the real world or for the business. And we can see that we truly need these kind of bridges because just if we look at like technical people who are data engineers, data scientists, BI engineer, or people who are doing I don't know, knowledge graph or those kind of things. Well, even like in those subcategories of one specific field, we can see language change and vocabulary change, speaking of the same thing but in different ways, which is challenging but very interesting. And I would like to ask you about now that we understand quite clearly what your intention is, a bit of a retrospective on your career path. You're a math teacher. You're bridging these gaps. Can you share a bit about your
Yeah.
your career evolution?
Yeah, sure. I started in Lebanon as a math. My dad actually taught me math. He's a math teacher, and he taught me at home math. So I credit him a lot to my dad. In terms of making me kind of think a bit outside of the box, because I didn't learn it at school. I learned it at home from a person teaching me to see it all at once, not to see like mathematics as independent from physics, from they're all like somehow tied together, even different fields in math. It's always nice to see the connection. So I ended up majoring in math and doing a master's in math in Lebanon. And my master's was in pure algebra, which you would not expect that I ended up where I'm at now. I loved it, but I always felt it was too abstract and it was disconnected. I could not use my brain to solve a problem that's happening right now. And I lived in Lebanon. It was a very chaotic country. Of course, there was war. And then I like, well, I know how to solve stuff, but I cannot use what I'm studying to solve real life problems. And
Mm,
I was getting abstract algebra was amazing, and I could prove things, but no, only probably 10 people in the world cared about what I proved, and not like real problems. So I ended up applying to do a PhD, and I came to New York City to NYU to do my PhD. And NYU is known for applied math, and it's one of the best schools in modeling, in probability, in partial differential equations. So I ended up doing my PhD in material science, which is a big shift from algebra. In material science, I did mathematical modeling. So at the material level, like if you think of the chip industry, like the silicon and the crystal, the Silicon Valley is because of the silicon chips and the integrated circuits, all that. So my PhD thesis was sadly not in the immediate crystal and material uh, industry. I did a mathematical model that was mostly about using partial differential equations to see how the shapes of these crystalline and thin layered crystals change. And all of that had applications in the semiconductor industry. But none of it had immediate application. So again, I was doing something but also far removed, from what I really want to do is I want to solve a problem that people right now care about. Again, it was an okay thesis, I would say. I mean, I did learn a lot of PDEs, partial differential equations, and I love it. PDEs like model the whole world. I mean, I loved how close I came to modeling the world and doing stuff that but I came close, but not as close as I really wanted. And then I ended up going to University of Michigan to do a postdoc after my PhD for 3 years. Um, and over there, I also wanted to change my specialty and also I kept on doing PDEs, partial differential equations, still modeling the world, but this time they were sending waves, using devices to send waves down the earth crust, and then part of the wave comes back. There are sensors that receive the signals. From these signals we want to actually see exactly how the earth is layered, right? We want to see inside the earth without going there. um, so that was good. I actually like that because it was closer to real life. I did it's this family of problems are called inverse problems because from measurements you want to see inside something, you can see all kinds of applications. I did learn even more math there. I learned that a lot of these mathematical methods, computational methods, are connected, like, I don't know, fixed point iteration, integration, blah, blah. And then And then I moved to for my current position at university at James Madison University. And then after a postdoc, you kind of move to a tenured position, tenured track. And then I had a child. Meanwhile, I got married. I had a child. And for all the people who end up having children in their careers, it kind of sometimes really blows up your life and makes you stop. It becomes the child is the priority of your life, as it should, as they should be. So I ended up kind of taking a break from research, still thinking about all these problems, but not publishing. And that was a good thing for me. I want to focus on raising my child. I had split from her dad and I was alone in the US with her. So I wanted to focus on her and give myself a break to really know what I want to work on next, what kind of problems I want to solve. When she ended up getting older, when she was finally independent, 11, I sat down and had an honest conversation with myself, and I thought, okay, this time I'm not gonna have people choose what I want to work on. I want to choose what I want to work on, and of course I got tenured, and that gives you a lot of freedom in what you do and when you do it. I mean, tenure is an amazing thing. It really unleashes the brain to whatever they want to do. And then at the time, data science was blowing up, and everybody was talking about data science, data engineering, data, and in my mind I didn't know what that was, and machine learning, and I'm like, well, it's really blowing up, I might as well know what it's about. It seems like it solves real problems in the world, supply chain and climate change, all kinds of energy, all kinds of stuff that I like. And then I kind of picked up the book Hands-on Machine Learning with Scikit-Learn, the good book. And so I was like, reading it. I'm like, oh, this is math, and I like it. So I ended up wanted to teach a class on math and AI, and of course AI. I mean, I grew up in war. I always thought about the human mind, the human intelligence, philosophy. So I'm kind of veered into that. There was a book by Norvig, the big AI book. So I also kind of wanted to see exactly where people are at in AI nowadays. And I also realized that there's a lot missing, and but there's also the math that goes in it has not been organized at all. And So I kind of sat down, and this is the direction that I took afterwards, and this is how I ended up here. Long story.
No, that's super interesting, and I feel like each element of the story is really inspiring and can also motivate people to go into the fields. And there is not one path to being a data scientist, a data engineer, because all this time you were already a data scientist, I guess. And when you picked up that book, you were like, oh, but this is what I do, or this is what I've done already, so nothing new. So you were just like, that must be a funny feeling when you read a book about a new topic that you're very excited to learn about, and you end up understanding that you're already like this this profile, and you're not learning anything from the book. I mean, I'm sure you can learn a few things, but that's a super interesting. I think that based on all this story, I have a lot of questions in my mind that I would love to ask, but maybe to focus on one in particular. You mentioned that you wrote a book, Essential Math for AI. Can you maybe share? You mentioned that you wanted to structure the math behind um, all the things that were being spoken around about the models and everything. So if people read this book, what they will learn from it, and why did you decide to write that book?
Okay. I I think the AI field has a lot of hype. It always suffered from hype, but at the same time, it did not. It's not like this hype is. It's not only hype. It has a lot to offer, and I wanted. The thing about math is. If anyone who knows math or who studied at any level in their life math, they know they cannot BS. They cannot they cannot fake. They cannot fake it. Math is either right or wrong. It's as clear cut as one and zero. So that grounding AI in math. And making people understand what AI is through math, and what kind of math at the same time goes into AI. It brings all of this hype. And all of this, if there are people who say are naysayers, no, it's good for nothing, it's gonna fail, and there are people who are this is gonna solve every single thing out there. In between these two extremes, like math, seeing it through the lens of math is what puts it all in the correct place, and in reality. And so that's one message I wanted to give through the book. And also it also makes you know where it's at now and what it's capable of, what it could be capable of. And there, in my mind, there was no way to tell the story, and of course, of intelligence itself. I mean, the fact that the universe, in my opinion, math is in it, and we're just discovering it, and and you can model absolutely anything through math. It is somehow an underlying law of the universe that's just there. So for me, and then there's intelligence, and people are thinking, what is intelligence? Like what makes us intelligent, etc. So also connecting that, I mean, if someone knows math, you immediately say, oh, they're intelligent, but there is a reason that that connection is made. So it couldn't be more fitting than to tell the story of AI through math, and to teach people math through AI, because people always think about AI intelligence some way, right? Like you see something, you understand it. Some people say, "Oh, I'm a visual person." Some people say, "I'm an audio person. I learned from audiobooks only." Some people say, "I need to sit down and write." Some people need to speak to other people. So language, vision, communication, like empathy, all of that are aspects of intelligence. So to actually understand that through mathematics, and that it's a two-way street between math and AI. You understand math through AI and your everyday thinking, and you understand AI through math. And you put AI in perspective, and its capabilities in perspective through math. So that is the main message of the book. Also, the other message of the book is in AI, it kind of brings a lot of math fields together. So there's many math. I told you I build bridges. So a lot of dispersed fields are there. Like people doing probability have no idea what people doing PDEs are, unless you're literally doing a probabilistic PDE, or a PDE whose, I don't know, underlying parameters are, I don't know, coming from probabilities or data, whatever. But unless you're in there, you are living in different universes, or mathematical logic, right? Or calculus or linear algebra. So again, like AI was a binding agent for all of these fields, and to see all of them in that way in the book. In the book, I never deviate from that. I always connect things. So and also not have it as a sit down and do formulas and write Greek letters, because I learned from my students. I've taught so many students over the years, and the students are usually starting off. They say the moment you write Greek letters, you lost me. So I wanted to write English words to explain all this mathematics, but with English, with words, and write as few formulas, as few Greek letters. It doesn't mean that I'm compromising on the rigor. I wasn't, but you can still explain a lot to people and connect these fields using math. So this was the message of the book. I think.
That's super interesting. You got me thinking on different things. First of all, explainability to people
Mhm.
and explainability of the models.
Yes.
Those are like two side mirror. Second of all, I think that I mean it's super interesting that I would like to maybe ask you more on a following question about like how do you approach teaching. Um, but I think that the first question I would like to ask you, you've mentioned, all right, we have these two extremes that we're talking about when we talk about AI. One is AI solving all the world's problem. The other one is AI is useless. And you've mentioned that you go through this lens with a mathematical approach, which don't lie and do not create another. It's not biased, let's say. Um, and but also you mentioned the different bridge business, the field of data, but into this field like mathematics, people who are doing probabilities. Um, I would have a lot of things to add based on your answer, and if I would like to do a summary, but ChatGPT would do it better than me. But basically, what I would like to ask you about is how do you see the gap between academy and the real world, and what can you tell us about, because you've been teaching and but you also want to solve problems, like
Mhm.
how did you target this approach, and what is your perspective on this gap?
Yes. Um, there is a gap. The the um, the gap. There's multiple ways I can answer this. So the gap originates from okay, the world of academia is usually trying to be idealistic, always like working with idealized models, always assuming you have all the data, or they're trying it's more like uh, and also remember, you're always trying to explain things to students and teach them stuff, and you're always trying to make it easy. So it's not like all academia's fault. There's a ton of ways, a ton of reasons why academia is the way it is, right? And there's also the sub communities in academia, and I'm sure it's the same in the industry, is like, oh, this community is focused on solving this one problem, and they're all like a lot of it is also there are gatekeepers to who can enter and who gets the credits. And I mean, of course, it's humans in the end, and there's a lot, and academia has contributed amazing things to the industry. And if you follow, say, the history of the evolution of any technology, it's always been between academia and some labs doing something, right? And there's always, as long as you're like talking to the labs, there's always some academics talking to the people making and manufacturing the stuff. Say, there's always some big uh, revelation that happens, like, for example, how transistors came to be, or all that, or the collaboration between NASA and the universities. I mean, it's I'm not going to talk it down. I mean, academia does amazing things, but at the same time, um, in everyday university life, say a mathematician. do they graduate now? A lot of our mathematicians say I are trained. The professors are they were trained in an academic discipline, but the professors stayed being professors. They never left the academic world, right? And so they were trained themselves to be and use that training to become a professor, but now they're training students to become professors. But no, not all students become professors, maybe one or two become professors, but the rest of them are going to use the knowledge you gave them at the university in some company, or to do data for some people. And you did not teach them how to do that. You didn't teach them the kind of problems that are encountered in the industry, the kind of limitations, even the resource limitations, the kind of data they deal with. So so a lot of students leave the majors. It doesn't have to be math, many other majors, and they feel they're unprepared to go and work in a company. They don't land running. They feel that they have no skills, and that happened to even us. When say even when I finished my PhD, and a lot of my the people, my friends who finished their PhD, um, they would interview at companies. I did not interview, but I didn't. I stayed in the academic path. But a lot of my friends would interview at, say, finance companies. We graduated at NYU, so Wall Street were there. A lot of them would go interview with finance companies, with labs, doing stuff, and they would not know how to even answer any of the questions. They just finished a PhD. So because they were trained to write papers and publish them, they weren't trained to actually sit down and do like work that benefits like one institution, or aligns with the mission of some company
Hmm.
or a lab. So this is there is a disconnect. So how I approached it is you have to talk to the people in the industry. You have to go. So we ended up in at least in my field to bridge the gap. When I started learning about data and AI and all of that, I realized that unless I talk to people in the industry who are actually doing this stuff, like people at Amazon, people at in my city, the fire department, transportation department, unless we talk to these people and know exactly what type of problems they're trying to solve. What do you use now? What's your infrastructure? What are you where are you trying? Unless you sit down, you bring your students with you, which I do. You bring with them, you sit with the people running these places, and ask them exactly what they're doing, what do they have, what kind of resource they have, what do you want to accomplish, and why is it not accomplished now, how can I help you. Unless there is, like, to bridge the gap, you literally have to sit with the people and teach students the whole process, and then you see the transformation in the students. Or if you can't really bring them with you, you have to tell them this is exactly what happens in that world, this is how this being used. And so yeah, there is a gap. And then a lot of initiatives are solving this gap now, like the NSF, the National Science Foundation in the US. A lot of its new programs are to actually bring the two together, like fund projects that bring academics at universities to solve real world problems from the industry, and they're providing. So this gap is recognized. Uh, and it's being solved now, and so that's, I hope that answers a little the question.
More than a little. I feel like it is a super interesting framing and a necessary one. What would you say to the people of the industry? Because from so the message is we don't prepare well very very talented people and very very smart people to like
Exactly.
so that we train them on on a framework of for doing something specific, which applies to certain rules and a certain ecosystem, but doesn't work anymore when you move in the industry. um, and so you've mentioned the key points to how do we deal with that. Now if you had to address to the industry, uh, what do they need? I mean, I mean, I, I would answer myself here. Like, I mean, PhD, like people who are doing PhD, people who are doing this academic path, very smart people, capable of solving a lot of things. But what would you say to the other side of the problem?
Yeah. I would say kind of give people a grace period where you get them up, because these people have the brain. They might have not encountered exactly what you want them. Like, for example, this is a good book. It's called System Design Interview, Alex Shu. It's a good book. He actually added me on LinkedIn, and I'm like, oh, who's this person? And I look up and I end up buying both of his books. But anyway, it's an
Good deal for him.
and it's actually a really good book. The reason I picked up his books, I'm like, oh, this is these are books that talk about things I've wanted to learn for the longest time in my life, and I've never really found them anywhere. Definitely not in an academic discipline, not in math, not in engineering, not in physics, chemistry, blah. Uh, so. Uh, uh, so give them a grace period to learn the stuff, because they will learn it. And also uh, yeah, I would say this is the most advice. On the other side, the other thing is also, do not get caught in the hype of the biggest new technology, because a lot of people in the industry, they want to bring AI to their ecosystem, and they don't know what it is, what it's capable of. They just want to say that my company is doing AI, or my organization is using AI to do stuff. So also, and I've seen that like literally happen. Or now it's AI. I don't know. 5 years ago, it was data, right? So
Yeah,
it was data science or data driven, right? And
yeah,
now it's like all AI.
exactly.
So you always want to bring the hottest new thing to your organization. Well, what kind of questions are you trying to answer using these new technologies that you haven't been answering before, or you have a gap in? So that's the other advice I have to the and the other advice I have to the industry, especially if you ever want to be really data driven, which eventually I think everyone should be data driven. I think
Hmm.
it's amazing. Data gives a lot of insights. If you model it correctly, you can do a lot with it. I would say the third advice is organize your data, and when you collect data, make it findable, make it explainable. Like the way you actually, whether you, I mean, there's, for example, the U.S. military. They have a ton of data sitting there. It's all super valuable data, and it's good it's so good to have the data. It's super important, but you also, when you're collecting that data, have it organized, have it, have a good governance structure, good if people leave, make sure like that the whole data system is dependent on one or two people who understand it, have it like a good observed system, a good governed system. So that's the third advice, is when you get your data, put it have put a lot of thought into how you're collecting the data and storing it, and finding it, and who owns it, and how to retrieve it, and so that's the other advice, is okay, become data driven, become AI, but you need your data in order first. So these are all the advices I think that come to
Those are
mind.
those are awesome advice. It made me thinking about too many things. But first of all, this show is called Let's Talk AI, and for the people who are listening, we talk a lot about data, and about, and it could be, I think it would be a more fair version to say let's talk data and AI,
Yes.
because when you're talking AI, this is like the last thing that you're going to do is like uh, modeling,
Yeah.
to do like, I don't know, like a regression model, let's say.
Yeah.
But this
And
is
which is
like,
what it is, honestly. AI is all regression, really. It's like
yeah.
regression or nonlinear regression. If you want another word for AI, it's nonlinear regression. It's like,
And so that being said, you said a lot of very interesting thing. I really liked when you mentioned when you take your class to the fire station, um, and you not only talk about data science, but you also ask questions about the architecture. How does the data arrive,
mhm,
and how everything um, is working together to know why am I seeing what am I seeing right now, like
100%.
those rows of data that I'm seeing, and whatever I will do with it, what is the context out of it. And
Exactly.
a lot of data science profiles have no clue about this data engineer part,
Yeah,
but it's so important because it is like being in a chaos place, but you're only looking at something that looks like a little paradise. But if you don't know that the data engineering around you is very messy and not fight, and you can't trust it, then there is no case to doing data science in this,
yeah.
before fixing all of that. And so that made me. I don't know if you want to comment on that.
I do 100%. It's you even ask about how you're getting this and exactly how it's organized at the database level, and even sometimes they ask like on the machine level on the actually what servers, etc. Because you discover that, oh, some of these values are, they don't have them for that day for some, I don't know, outage or something, so someone sits down and literally puts in things by hand, or sometimes a bus driver in the transportation like literally logs things. So all of this information is important, like just because at some point you need to know, uh, I mean, these numbers determine things later, and you need to know where these numbers are coming from and how they're organized.
Mhm.
There's multiple layers to what you said that I want to comment on a couple of things that you said. um, People, they don't only need the that side of the story, they also want to see the business value side of the story. After you had this nice stuff, and you create the charts, or find the numbers and metrics, exactly how is your business using these numbers to get funding, or to sell more product, or to get more ridership to the, more usage, more customers. You want to know exactly with what they have now, how are they using it in their business model. So you're, as a data scientist, sitting like right there in the middle between what the engineering data engineering people are doing, and between what the business and its mission and its values and its money is very important. It's what where it's fun, how are these numbers getting you more money, and
Hmm.
where do you want to go with it, or how is it getting you, I don't know, more visibility or more votes if you're a political campaign. Exactly, you're a data science, you want to know both sides of the story, because you're right there in the middle, and that's not a nice place to be if you don't know either side, because then you do stuff, then you're just basically a person who's playing around with some charts and some pictures and some models, and it's fun, but is it adding value either way? No, you can add value to the engineers by telling them exactly how you want your data, and you can add value to the business people by saying where they want to go and somehow take them there. So
Hmm.
so
Yeah, totally. That's super. That's fundamental, and like when when we are clear on what's the output of it, even though I'm not going to do it myself, but like what do you want to, like, what decision do you want to make based on what I'm going to provide you,
Mhm.
or how do you expect this to succeed, or like
Exactly.
what would mean, how would you define success
Yeah.
after I've realized whatever we're talking about.
Whatever.
And
100%. In not only success. Oh, you said it left my mind. It will come back. Yeah, it left my mind. But you said something made me think of something. It's
well,
just so.
if you remind it, just get me in. But yeah, also one thing that so now that we have clear that a data scientist needs to have a little bit of curiosity out of the system, because maybe like you mentioned the school bus guy, or the bus guy who is entering the data himself, maybe he'll enter like 3 euros in 1 week, and the week after 10 euros, and the week after 2 euros, and
Exactly.
how will that impact everything? And like you need to know. And if you're just come to the data and you just look at it, you'll just see dates and you'll just see irregularity,
Yes.
but you need to know what's going on and how this data arrives here to like make the good decisions. And so that is very interesting. I was very curious. So I know you're writing a new book,
Mhm.
and I want to ask you about it. But before that, I would like to ask you, um, how do you see coding? Any language, it can be in any language, but you've defined very well how you see math in the world.
Mhm.
So how do you define the relationship between math and coding?
Wow, I love that question. Um, so one of the chapters of my new book is on programming. I'm not going to teach people how to program. But I will definitely talk about exactly where programming sits in the hierarchy. So I start with the underlying infrastructure and the hardware. And on top of that, there is the communication systems between the hardware. You cannot really have hardware sitting alone. You need communication and satellites, all that stuff. So all of that is infrastructure. And then on top of that, there is the data and the data centers and databases and how you organize data and query it and retrieve it from that's living on this hardware and communicating between the hardware. So that's the third chapter. And then the fourth chapter is programming. And there's a reason it's the programming is sitting there in the hierarchy, because programming in the end is instructions, is giving instructions to the machines to do what they want, what you all want them to do, right? So it's like you're controlling these communications with programs with all these instructions. So and have it sit at that level and before the computation and the modeling level. It's kind of because I think it actually belongs there. That's where it belongs. Um, it, um, at some point, I mean, what I see a value in the language models in the AI is honestly is helping humans skip the level of programming and kind of have the infrastructure what their machine want their machines to do, and the higher level, which is the models and the machine learning models and the math models and the operations research models like the supply chain, etc., logistics. Um, and then the programming will be hopefully done at the machine level, not by us, because in the end, the programming is languages that that tell the machine to do what we want them to do. It's the intermediate between us and the way where we want to be and what the machine instructions does, like exactly like put this pixel in this screen and or put this table or do this computation, right? So my hope is that programming will be something that we in the future, because of language models, we will not have to do ourselves. It will all be automated. But for now, what programming helps with is, for me, I think the important programming languages are honestly SQL for database querying and stuff, and for and um, Python, of course, and Rust for machine learning, and I don't see need beyond those for now. Maybe I skipped something that I have to open my new chapter in that. But this is how I see where programming is situated, and the value of programming, and whether all now do I teach my daughter coding? Now, yes. I think we're not at the level where the language models can write all the code for us that we want them to, but at some point, I'm hoping that we won't have to, and then we just teach them either the infrastructure on databases, etc., or the higher level, and the middle language is just, we're gonna skip it. I don't know if I answered your question, but this
Yeah.
is how where I see the position of programming in the world of
Hmm.
data science and AI.
Right, because you can have, for example, you have you've solved a problem with math, and now you want to implement it in systems,
Mhm.
and you're using programming. I am aligned with the vision of programming being skipped, and a lot of the majority of the users in the future. I'm not sure if it's long term or how or what it is. But I am aligned regarding we're all going to be prompt engineers,
Yes.
just doing prompts.
Yeah.
That being said, I think programming in itself, even though will be enhanced by new technology to do it faster, better, and so the learning curve is more approachable for anyone. That being said, I think um, for to be this prompt engineer, to have this vision and align all the systems just by doing sentences with large language models or just a language model, I believe that the person who is doing the prompts needs to understand the coding logics that goes behind, so
Yeah.
that the questions are very specific. And what we're seeing today with large language models is like it's a very powerful tool if you have powerful questions and you know what to ask,
Yes.
but it is a mediocre tool if you are asking mediocre questions, but then you're assuming it is a mediocre tool because you're not asking the right things in the right context or giving the right information, which is very challenging. And this is why it might be very important to know what goes behind with the system and how the language work and how it have been architectured specifically to be able to be this prompt engineer, at least in the nearest term. But then maybe this will be overpassed and I can just write me a website where it does this, which is already is, but with the database that does that. And I want to be it e-commerce, and I want to do this, and I want to have these
Yeah.
models, and and everything will go along.
I agree 100%. I mean, if I'm sure we all Googled something in our life, many things, and sometimes you have to refine your Google thing to get what you're really looking for. And I don't see this as different. And the other thing is about the barrier of writing code itself in a certain language, um, in a certain programming language, whether it's C or Python or whatever. Um, the way I see that uh, what's the word, the benefit that the language models are gonna give us in that sense is the same benefit that the invention of a graphical user interface in computers gave to the world. is that it made it democratized computers and made them used by anyone, by artists, by business people. People have nothing to do with programming ever because of the graphical user interface. It put a layer where people can use instead of literally writing code, and the GUI is what's actually um, doing in the background the actual lines of code. So I see it as very similar. um, it it's like you said, we have to understand the logic. I mean, when I sit down and model something for whether it's I don't know, my material science or the fire deployment project, when I model anything, I have to sit down and understand what problem I want to solve. I model it, but then I tell my student to program it, right? And they do. And did I click a button? I did not click a single button. I do write my own programs as well. Don't get me wrong, but when I don't have to, I don't. And then I come back. They come back with results, and if I don't understand the model I wrote and what kind of logic I wanted in it, I can immediately tell if they did something wrong or not with their code and stuff. So you see, it's a different. You have to understand if you to get your correct to get reliable results, which many models don't have any reliable results. It's a different story because all machine learning models will give you numbers, right? Who knows what the numbers, if they're built on something great or not? No one knows. But um, but my point is about programming in particular is it can be outsourced. Whether you outsource it, I outsource it to my students. Well, don't do it unless I really have to. But you can outsource it to machines, and it's actually, honestly, since it's a language that's supposed to interact between human and machines, might as well make machines do it, right? So this is how I see it. Yeah.
Hmm. Super interesting. Could you share maybe the fire department projects? Uh, Maybe how you've like the problems you've been tackling and how you've been approaching it from the databases and then data science perspective, and how you've been working with your students,
Mhm.
just so that we can have some insights about how
Yeah.
you approach these kind of problems.
Yeah, so I also want to give credit here to my colleagues at JMU as well. So one of my colleagues made the contact with the city, with our city, and asked them if they had projects that needed some math and data science and AI. Um, and then they put us in touch with the fire department and the transportation department, and they have the most amazing problems, honestly. With the fire department, they have multiple goals. They got $4.5 million funding to build a new fire station, and they wanted to use their data, their historic data on they have four fire stations already in town, and they want to build a fifth one, and they wanted to use the data to know exactly where the optimal location that will maximize the coverage of the whole city and minimize response time, and also make the most vulnerable populations of the city um, reachable in faster time, right? So it's a super mathematically, it's an awesome problem. It's optimization. And also in terms of data, it was very nice problem because they had data. Of all the calls they've received, and then we also a lot of this project is also a geographic information system, because you need location is very important, and
Mhm.
mileage, and so they need the response time to be under 4 minutes, and also in mileage, you need to cover like road miles, and and also you wanted to know information about each house and the structure and what kind of people live there, how old do they are they. We have, it's a university town, so students have parties and there's they're prone to fires and and all of that stuff. So that was the kind of project we got. They also had a different goal, which is enhancing the insurance ISO rating, they call it in their language. Oh, by the way, we had to learn their language. So many times we'd ask them, what does this mean? What does this acronym mean? Like, you have to sit down and by the end, in the beginning of the project, I had no idea what firefighters did or talked about or valued, and then by the end of the project we were speaking their language. We both had to actually agree on the vocabulary and teach each other our vocabulary.
Hmm.
um, anyway, so they wanted to enhance their standard of cover rating, because that if a city is rated more safe by the national rating, then more business, the insurance goes down, the insurance fees, so more businesses come. So it really is a good thing. So we
Wow.
had to use their data to see exactly where they were underperforming and how to bring that up, like exactly what. So it's an awesome project. There's a lot in it. It keeps coming. Um, Also, the transportation department project is really amazing. But with that project, we had the data. We did a lot with the data, and then we discovered that the data was all wrong. It was all scrambled.
Oh.
The data what they gave us, and it was an unfixable. It was at a database level, and I it's actually the reason that prompted me to write the new book was exactly that incident. Is I realized that I because I don't understand databases and how data gets into databases and how it gets retrieved from databases, um, I could not fix the data that was given to me or even give advice on how to fix that data. So we had to, I mean, of course, the model is still correct, but we
Mm-hmm.
have to use an older data set
Mm.
to
Mm.
actually do so. So it is, so that's, it's all interesting problems. Get your hands dirty in a good way.
Mm. We've heard this sentence a lot in this podcast. Yeah, you need to play with data and not only like real world data, and there are a lot of data sets out there available to play. I find it amazing that you're working with students to solve real world problem. And I know that as a student, if I were to go back in my master or in my degree, I would like to have this kind of opportunities to just like in the end, when you solve this problem and when you do a good job about it, you have real world value. You're helping people who are helping saving lives.
Yes.
You're helping your city achieve more business and grow more prosperous. So it ends so many, and from there are so many indirect um, repercussions,
Yes.
and ways to. I mean, it's fascinating, and I love it, and um, and if that's in your second book also, well, maybe can you share a bit about your second book?
Yes. I- uh, uh, the second book, it really fills the gap that I just talked about. Like, I have always existed in a good world where data was awesome and curated, and I could write a model and I could analyze the model and I could do math on the model, any math you want, like even conversion and analysis stuff that is not easy mathematically, but it exists in a very ideal world.
Mm.
So I was sitting in the middle on the modeling, computation, analysis, and decision making, if you want, side of things. Like it,
Mm.
But there is, before that, there is the infrastructure and the communication and the databases, that I and the programming that I did not know 100%, and I still don't. I mean, I am writing about it now, so I am learning a lot. And then the middle of my book is what I said: computation, AI models. I mean, AI models at some point is a lot of it is machine learning, and it's more like more advanced models of machine learning, like nonlinear stuff. If you see it from a math perspective, it's really all doing mathematically the same thing, learning a function or learning a probability distribution, and that's all what they're doing, honestly. So that's there in the middle of my book. And at the end of my book is, I think, things that are super important that people need to learn if they want to be in the AI and data landscapes. And there's three or four things, and I'm going to list them. It's going to be geographic information systems, GIS. They need to learn that and see how it. You cannot make decisions in AI and stuff without a lot of real world problems are attached with locations, and just
Mm,
how it is, right? So that's GIS, and also networks and graphs. That's a super important skill. Like, you need to know how to be comfortable with graph modeling and networks. And also games, the game industry. The gaming industry has given a ton to the AI and data fields,
mm,
and the AI and data fields gave it a ton, and it's a huge industry. It's actually an industry that's has billions I mean, it's bigger than the Hollywood and music industry combined, right? So gaming, and it has a lot of um, if you learn what goes in that industry, whether from the data, AI, or math perspective, you are, you know, a lot of stuff in it. So it binds also a lot together. And also the book ends with the business value. The As I said, um, if you don't know what your value, yeah, what your contribution is, it's just like you're saying, the students knowing exactly how this work is going to get more funding or attract more businesses. You need to have that together with the story. So the book is called Foundations of AI and Data. So if you want to be in this landscape, the book should actually give you the whole story, all one stop in one book. So you read the book, and hopefully you are ready to talk about these things, to interview about them, to you wouldn't know exactly all the details, but you would definitely know the overarching
mm.
picture. So
That's uh, that's super interesting. I'm looking forward to this new book you're writing. Um, well, I'm going to ask you the three little questions that I have at the end of each episode. But before that, I'm still thinking about what you mentioned, having data that you built a ton on top of it, and then it all goes away because the foundation is not correct. And to be fair, I believe that data science is going to be easier. I mean, it's going to be replaced faster than data. Like data scientists are going to be replaced faster by large language models or whatever than data engineers because we'll need to build all these architectures, we'll need to build all these systems. That being said, I'm not saying that the scientists will be replaced, not at all, but I believe, truly believe that the role will evolve and you'll have more tools to solve more complex problems. But in the end, you need to have the good environment to be able to solve those problems. And you mentioned the video industry, and what's great about video is the gaming, sorry, industry. What's great about it is, um, if you're in a, for example, you're building, I don't know, I'll just invent something. Maybe it's too complex for what it is, but if you create a character that have responses that change through times because based on the actions you take with these characters. I don't know, it generates, let's say, it have an LLMs behind, and his mood change, or whatever, or I don't know. um, but because all the systems is architectured well, because it's a game, then it will do a good work. But the challenge is, in the word, we need to capture very well the essence of the problem, which is the data engineer part, like setting up the database. And if we've captured well, we'll be able to have to build great roadmaps, or get great maps, or what we could see as maps, because the data scientist, in the end, to me, to my perspective, is just building maps, building potential, confirming hypotheses. Maybe not seeing clearly, but if my hypothesis is that, and the data shows this, and I trust in the data, then I'm going to walk in that directions,
Yes.
aligned with my first intuition of maybe we should go there. What does the data say? But
Yeah.
it doesn't mean anything if there is no strong data foundation. So
Hundred
I just
percent.
want to reflect on that. Speaking, would you add something?
I would say I agree with everything you said. It's so true. I think the role is evolving, and it has to evolve in the direction that you described. Um, i- yeah, I really agree with what you said. It's how I see it as well.
That is, I've learned a lot in this episode. So my three little questions before, I want to thank you so much for coming on the show. I've learned so much. I'm really looking forward to your new book. The first question that I would like to ask you is, you've shared a lot of tips for people who are getting in the industry. You've shared how you would do it. Would you have like one main advice? You mentioned earlier, get your hands dirty. Uh, what would be your advice for someone starting, or someone still in his PhD or his master, her master? Um, would you have tips and advice?
Yeah, I would say there is a lot of information out there. It's so easy to feel overwhelmed, and it's so easy to feel lost. And there's a lot of information out there that's either wrong or just not in the right context. It's just people are talking because they like talking. So I would say, first of all, do not get overwhelmed. To start with the little questions that are literally in your head. Like ask, like what you don't understand, you write the question down and ask it to someone, either to the internet or to someone you know, and surround yourself with people who are generous with their knowledge. A lot of people in the industry are generous in the sense that they either talk about it, they write about it, or they, if you ask them questions, they would answer you, or people at your school, other students. And sometimes I'm watching a TV show and I learn something or look it up. So just always try to answer the little questions and follow the leads. And also, um, see before getting your hands dirty, it's good to also see try to understand the big picture and where the thing you're learning falls in the big picture, like exactly where you're situated. You don't have to understand any detail. No one knows everything, and no one knows all the details about everything. But what you want to know is exactly where you're situated, or your problem you're trying to solve in the big pictures of things, or on the how does it align with the big goal. So that's another advice. Of course, answer your little questions, keep learning, and yes, at some point do get your hands dirty, but not right away. I would say understand the big things and then try to get your hands dirty. Unless someone forces you to get your hands dirty, then you sit down and do it. But yeah,
When you're being forced, it's sometimes a good way
it's a good
to,
thing.
like, you don't have choice, so you need to understand what you're doing and you have to
Yeah,
do it. So there is no questions to ask, and you just need to figure a way,
hundred
which is
percent.
a, maybe it might be stressful, but it is an effective way to to learn something.
It's a good thing.
um so my before asking my last question, I'd like to ask you, where can people see more of what you do, what you publish, your books, where they can follow you, ask you questions?
Yeah. So, well, this is my first book is already published. So here it is, Essential Math for AI. I on LinkedIn. I usually. I By the way, I read all the messages, and I reply. I end up replying to all the messages. Sometimes not right away because I get a lot of them, but I do read them, and sometimes what you all send is super amazing that I end up saving it or copying somewhere. So LinkedIn is a good way to reach me. I Yeah, I give talks. I talk on podcasts. Yeah. But LinkedIn, I would say, is the best way.
Awesome. And last question, and I thank you again for coming on the show. It was amazing to have you on the show and learning from you. My last question is: do you have any message for the Let's Talk AI community? It can be motivational, it can be personal, it can be um, how you see the future, it can be another advice. What would
Yeah,
you let
that's a
us
good
with?
question. What's a message for the AI and data community? I think keep working and organizing what we all are trying to organize. I know a lot of people like. Um, I'm gonna mention a few names, but I'm sure I'll miss a lot. Like Joe Reese, Andy Petrella, Matthew Housley, Karen Kilroy, Bonnie McLean. Like, there's a lot of people trying to organize this stuff, and so keep doing what you're doing. Keep trying to make sure that the data is good, ethical. Explain the capabilities, just keep talking, and keep trying to sit down and do it the right way. I feel like a lot of people are scared of these technologies because they're scared that they're not being done ethically or in the right way, and I agree with that. A lot of it is not done right. It's like fast and just, I don't know, harnessing data, say, from the internet without giving credit to anyone. um so it's not a good, a lot of it is being done not the right way. So try to do it like thoughtfully, mindfully, organized, and the people who have a um who like to organize these things, like sit down and write it down and talk to people about it, to spread the good message and the good capabilities at the same time. uh, Also talk about how things can go wrong and how to mitigate against that. So that's the advice.
Thanks a lot. Thanks a lot for everything. Really looking forward to the second boot. I wish you to have a wonderful day, and we'll speak soon, and maybe for another episode. And let us know if you have any questions in the comments, and we'll answer all of them. Thanks a lot, Hala.
Thank you, Thomas.